Tonight we are continuing with Murderous Maths. We are up to how far away is the horizon?
Whoa!
If you are standing on a beach with the edge of the sea just touching your toes, then for a quick answer check this table. How far your eyes are from the ground? 1.2 metres. Small person. 1.5 metres. Medium person. 1.8 metres, tall person. 5 metres, you're a giraffe. 30 metres, you're tied to a kite. Obviously, tall people can see further than small people. So if you're not tall, you can always build a sandcastle and stand on it. Oh, actually, so they're saying for a small person, the horizon they see is 3.91 kilometres away. Whereas for a tall person, the horizon they see is 4.78 kilometres away. And if you're a giraffe, it's about 8 kilometres away because you can see further when you're tall. That's cool. So, you can always build a sandcastle and stand on it. A sandcastle that's 30 centimetres high will let you see more than 400 metres further away. Note, in these diagrams, the size of the Earth has been reduced. Normal person, horizon 4 to 5 kilometres. Lighthouse keeper can see further.
0.5.
Oh, is it 4.5? Okay, cool. Whereas if you stand in a hole with your eyes at the ground level, the horizon distance is about 0 kilometres. How did we work it out? We used the special Murderous Maths horizon formula. D equals 3.57 times the square root of h, where D is the distance to the horizon in kilometres and h equals height of your eyes above the ground in metres. So if your eyes are 1.5 metres above the ground, the distance to the horizon is 3.57 times the square root of 1.5 equals 3.57 times 1.225 equals 4.37 kilometres. Some people use the formula D equals the square root of 13h, which is easier to remember, but the answers are about 1% too big. Hey, you cheats. Why should anybody trust your Murderous Maths horizon formula? I bet you just grabbed any old numbers and stuck them in there. So there. Who wrote that note? These notes are getting irritating now. We did not just grab any old numbers. To prove it, we'll work out the horizon distance with Pythagoras' theorem, which we saw back on page 25. The first thing we need is a right-angled triangle, and this calls for some devious thinking. Imagine two lines drawn from the centre of the earth, one to your feet and the other to the horizon. These lines will both be the radius of the earth, which is about 6,370 kilometres. Now imagine a line from your eyes to the horizon. This line is the distance we want to find out, and rather helpfully it makes a tangent with the curve of the earth. A tangent is a line that only touches a circle once. The angle between a tangent and the radius it touches is always 90 degrees. You can see from the diagram we've got a right-angled triangle. If we take away the earth, it looks a little bit clearer. R equals the radius of the earth, which is about 6,370 kilometres. H is the height of your eyes above the earth, 1.5 metres. D is the distance to the horizon. Of course, in real life, H is tiny compared to R, so the shape of the triangle would look more like this one, but it would be even longer and pointier. First, we need to work out the length of the R plus H side. We know H equals 1.5 metres, but as the other distances are in kilometres, so we need H in kilometres too. We divide 1.5 metres by 1,000 to give H equals 0.0015. Now we know that R plus H equals 6,370.0015 kilometres. That little extra 0.0015 on the end might look tiny, but it makes all the difference. Pythagoras says 6,370 squared plus d squared equals 6,370.0015 squared. We can move this around to get d squared equals 6,370.0015 squared minus 6,370 squared. Now we do the sums. D squared equals 19 minus 11. Is it? No, 19.11. So finally we get D equals the square root of 19.11 equals 4.37 kilometres. That's the same answer we got with our formula. So the formula works, okay? Oh, touchy. Anyway, I bet your horizon formula doesn't work for the moon. Ha ha ha. Oh, yes it does. We just need to make one little change. How far away is the horizon on the moon? The radius of the moon is only 1.737 kilometres, so the horizon formula has a different number in it. D for the moon equals 1.86 times the square root of h. Suppose the moon was a perfect sphere without any mountains, craters, abandoned alien caravans, or talking trees. Then, if your eyes were 1.5 metres above the surface, the distance to the horizon works out to be 2.28 kilometres, or 1.41 miles. So even though you're still at the same height, the moon horizon is about half the distance away compared to the Earth. One good thing about being on the moon is that gravity is about 1/6 of Earth's gravity, so if you like, you could jump up and to maybe a height of 3 metres. In this case, your total eye height would be 3 plus 1.5 equals 4.5 metres. If you plonk this into the formula, you'll find that when you jump up, you can see nearly 4 kilometres. How lovely! So don't forget to take your camera.